Alright, so this is section 10-2, circles. So pretty much all these conic sections will have their own circle, so all these conics will have their own circle, their own section, sorry, and we'll see how we can kind of hopefully better understand these beyond the introduction that you got with 10-1. So we want to write the equation of a circle, and we want to graph a circle, identify its center and radius. And hopefully most of that should be pretty easy for you to be able to do. Keep in mind, this is actually the very important part of this. Equations of a circle. Well, I guess there's two different types. There's a basic one, and then let's say a little bit more when we move it away from the center. Your basic equation is when the center is at 0, 0, you're just saying x squared plus y squared is equal to the radius squared. Automatically, that's it all the time. If you move the center somewhere else, it's h, like any other point, it's x minus the h squared plus y minus k squared equals r squared. And I'll show you how I kind of make sure I don't make little sign errors with that when I do that one. Okay, so let's look at an example here. And we've got x squared is equal to y squared is at 9. Okay, first obviously identify the center. We're going to start with this one with graphing. So let's look at the equation. We want to identify the center. Since I'm not subtracting anything from the x and y, I'm going to say the center is at 0, 0. Take the radius. Take the square root of that number. So the square root of 9 is 3. Okay, so that means from 0, 0, I am going to go 3 up, 3 right, 3 left, 3 down. And maybe not necessarily in the same order. Okay, and then just connect them. And you've drawn your circle. That's it. Pretty easy. If it was multiple choice, you'd be looking for something that would do that, and you would count that radius. Okay, so there you go. That's drawing the circle, and probably one of the best circles I'll probably ever draw in my life, but oh well, I'll be happy. Okay, so let's look at this one. This example here, I've got x minus 4 squared plus y plus 3 squared equals 4. Now I purposely did this one so that way you can kind of see how this would work. Now the center, when I'm looking at it like this, the x minus at y plus, or the numbers with parentheses, I always think opposite. Again, parentheses, we want to think opposite. So opposite of a minus 4 would be positive 4. Opposite of a plus 3 would be negative 3. Okay, that's your center. Take the square root of 4 and you've got a radius of 2. So at 4, negative 3, I'm going to go up 2, to the right, to the left, and down 2. Connect those and make my circle. There you go. So you'd be looking for that proper radius. I would guarantee on a multiple choice test I would have one that would have been at negative 4, positive 3, and seeing how many of you would choose that, because several of you probably aren't listening to this on, like, you're just watching it play and you're not even paying attention. So hint, hint. Okay, here's a small example of me trying to be tricky. 8x squared plus 8y squared equals 56. Notice you're not seeing anything subtraction. Before you graph, you need to get the x squared and y squared by themselves. So let's divide out the 8, and you got x squared plus y squared equals 7. Okay, then you're thinking, okay, the center is at 0, 0, and the radius is at square root of 7. Well, how do I do a square root of 7? Well, you get a decimal, and you find out the square root of 7 is about 2.6. So you go somewhere in the middle, and you draw it from there. Okay, not a really difficult example. It should be kind of easy. I probably will squeeze this in with inequalities. It should always be like this. If it's less than, it's going to be shade inside. If it's greater than, it's going to be shade outside. So that should be kind of obvious. Yeah, we should have one for the multiple choice. Why not? It should be fun. At least for me. So let's look at an example of that. So again, divide out the 2 and have x squared plus y squared is less than 25. So your center's at 0, 0, and you have a radius of 5. So that would mean you'd start at 0, 0 and go 5 up, 5 right, 5 down, 5 left, and so on and so forth. You can make it a broken line. Y'all should remember this stuff. Like there's no line underneath the inequality. Make it a broken line. The line underneath you would make it a solid line. And then shade in between. Or shade inside, not in between. And there you go. Yes, I know, intensely hard. So now let's go the opposite way. Let's write an equation from, say, a graph or given a point and a radius, something like that. So let's do this one. Let's write the equation of a circle, and you can see here the circle is at 0, 0. The center is at 0, 0, has a radius of 1, 2, 3, 4. So then if you know the radius and you know the center, you go from there. So the equation would be x squared plus y squared because we didn't move anywhere, we're at the center, and then square 4. 4 squared is 16. There you go. Easy. Okay, now let's write the equation of a line given the point and giving you a new center that's not at 0, 0, and let's try a different radius. Okay, so this one here, the center is at 3, negative 2, and let's give you a radius of 6. Okay. So here's what I do. This is where I try to avoid sign errors, because I think a lot of times when you're going this way from the center to the equation, there's a lot of simple sign errors that you can make. So notice here, what I've written is x minus parentheses, y minus parentheses equals. Okay, so I've already put the minus. Okay, and then I got 6 squared is 36. I know I'm squaring the radius. I just put the 3 in the blank, put the negative 2 in the blank. Oh, a minus and a negative, they cancel each other out, leave me a plus. There you go. That is the way I work to make sure I don't make little sign errors. And that should hopefully make it easy. I'm not sure if it will, but hopefully it will make it easier. That's what I would do. Because again, multiple choice, I'm telling you right now, I will have those where you can make those simple sign errors, and then you're not going to be like, sir, it was you made it hard. No, I'm making it easy. You just need to pay attention. Alright, I believe this is my last example here. So let's see here. We've got a center at 2, 4 and an endpoint somewhere else. Okay, so I'm not going to give you the radius. So first you got to find the radius. So we got a center at 2, 4, we've got a point at 8, 12. How do you find the radius? Well, you find the radius using the distance formula. Square root of the x's, subtract the x's squared, plus subtract the y's squared. Okay, and don't even worry. I mean, you can type that all in the inspires. Remember, you can type that on all at once, and I would. If you didn't, again, keep in mind, don't even have to worry about the negative answers. Keep them positives, because the squares will take care of that anyway. So basically I'll end up with 6 squared and 8 squared, which is 100. So square root of 100 is 10. That's my radius. Okay, now let's look at my equation. X minus squared plus y minus squared equals, well, 10 squared is 100. Okay, let's put the 2, because my center goes in the parentheses. Remember, the center goes in the parentheses. So I'm going to put in the 2 and the 4. Don't need to worry about changing signs because neither one of them was negative. Equals 10 squared is 100. And there you go. That's it. You're done. That's basically what I want to do with circles for section 10.2. You should be able to handle the assignment that you'll be seeing. Shouldn't be that hard. And there you go. If you do have any questions, make sure you write them down. Let me know. Thank you very much.